we are going to start calculating molar mass of a gas. Molar mass of a gas. And the equation is molar mass equals, or MM equals dRT over P. Now D stands for density, and we know density is mass divided by volume. We know that we learned PV equals nRT, right? And so when you write volume equals nRT divided by P, right? But in here, molar mass, whenever the volume here, you can see when you write volume, it's mass divided by density. So if we write the volume here in terms of volume, it's mass divided by density, and nRT divided by P. Now, for moles, when we write, I'm just explaining how this equation comes from. It originates from here. The only thing, we express volume in mass divided by density, and we express this one, it's going to be mass divided by molar mass. This is grams, so mass divided by molar mass. And we rearrange, when we rearrange or we cancel the mass both sides, you get what? Molar mass equals dRT over P. So basically what I'm saying, that this equation is originated from PV equals nRT, right? Because instead of n, number of the moles of gas, we work on this equation, and instead of volume we plug in this equation, and then we can derive this equation. Alright? So that's just for your understanding. And when you plug in the unit, density units is gram per liter, R unit is liter, atmosphere, mole, Kelvin, and temperature is in Kelvin. I'm defining units of each one. Divided by pressure is in atmosphere. Now when you do that, you see that liter cancel, right? Atmosphere cancel, Kelvin cancel, so you get a gram per mole. That's for molar mass unit, right? So dRT over P, molar mass equals dRT over P, this equation. Alright, now we are going to apply that equation in a exercise, in a problem solving. So let's go to next one. What is the density of F2 fluorine at STP and in gram per liter? So density we need to find in gram per liter. Now we know this equation, molar mass equals dRT over P, and when we rearrange this equation, we need to find out D. So P times molar mass divided by RT. Alright, now we need to plug in, molar mass of fluorine, molar mass of fluorine, which is 19.00 grams per mole. Pressure 1 atmosphere, because STP, standard pressure, is 1 atmosphere. R is 0.082, and a temperature 273 Kelvin. Okay, so when you plug that value, you get density 1.70 gram per liter, and so that's where you can calculate density of fluorine at STP. Okay, I am trying to find another example on okay. One more calculation, one more problem we are going to work together. What is the density of NH3 at 800 torr and 25 degrees Celsius? We know that the molar mass equals dRT over P, and we need to reorganize. So P molar mass divided by RT. Now what's the molar mass of NH3? 17. Fantastic. So 17 grams per mole, 800 torr, so we need to convert into atmosphere. So we need to divide it. 800 divided by 760. R is 0.082. And temperature 273 plus 25, because we need to convert into Kelvin. Now we've converted. This is grams per mole.
Where did you get 800 over 760?
Because 800 torr is given here, and when you convert into atmospheric, you divide by 760. Remember this conversion, 1 atmosphere equals 760 torr. So that unit conversion we need to use it, because we need to convert into atmosphere. Alright, so when you do that, you get density 0.73 grams per liter. So you can calculate